You have seen black thousands of times. Black clothes, black ink, a dark room, the night sky, and you have also seen colored light. Red light, green light, blue light, violet light. So here is a strangely simple question. If red light exists and blue light exists, where is black light? Not ultraviolet light, sometimes called a black light. That radiation is mostly outside human vision and can make fluorescent materials glow. I mean actual black light. Light that enters your eyes and looks black. Why does that seem to be missing? The answer begins with what light actually is. Visible light is a small portion of the electromagnetic spectrum. Different wavelengths within that range can produce different color experiences. Longer visible wavelengths tend to appear red. Shorter ones tend toward violet, with other spectral colors appearing between them. But nowhere along that sequence do you arrive at black. There is no black wavelength hiding between red and violet, and the reason is almost paradoxical. Black is what you tend to experience when very little visible light reaches your eyes from a region. So asking for black light is a little like asking for a sound that creates silence. Adding the thing removes the condition that produces the experience. But that creates another problem. If black is not a wavelength of light, why do we call black a color? Because color and wavelength are not the same thing. Light is physical. Color is perceptual. Inside your retina are photoreceptors called cones. Human color vision normally begins with 3 classes of cones that respond differently across the visible spectrum. Your nervous system compares their signals and processes them through multiple stages. What you consciously experience is color. That distinction matters because there is not a simple one-to-one list where every color in your mind corresponds to its own unique wavelength. Consider magenta. You can see magenta perfectly well, but there is no single wavelength in the visible spectrum that simply is magenta. Magenta can arise when your visual system receives combinations of light that strongly stimulate the long and short wavelength-sensitive cone systems relative to the middle one. Your brain produces a perfectly real color experience even though you cannot point to one location in a rainbow and say, there is the magenta wavelength. Black is different again. Imagine a black sweater under ordinary white light. The sweater looks black largely because its material absorbs much of the visible light falling on it and sends relatively little of that light toward your eyes. Now put that sweater in a completely dark room. It is still a black sweater as an object, but visually something important has changed. You cannot actually inspect its color because almost no light is arriving from it for your visual system to analyze. This reveals something easy to overlook. Seeing is not simply your eyes detecting properties attached to objects. It is an interaction. There is a light source. There is an object that absorbs, reflects, or transmits different amounts of that light. There are photoreceptors in your eyes. There is neural processing. And finally, there is your conscious visual experience. Color emerges from that entire system, which is also why the same object can look different under different illumination. A surface does not contain a tiny supply of color waiting for your eyes to collect it. Your visual system is interpreting light arriving from the world. And it does something even stranger. It constantly compensates for changing illumination. Walk from bright sunlight into a dim room, and, after some time, your visual experience adjusts. Look at objects under different lighting, and your brain often helps maintain a relatively stable impression of their colors, even though the light reaching your eyes has changed. So when you see black, your visual system is not detecting a special black wavelength. It is interpreting a pattern in which relatively little visible light is reaching you from that part of the scene, in context with everything around it. And this is why shining more light cannot produce true black light. You can shine red light. You can shine blue light. You can combine different wavelengths and create many different color experiences. But if visible light is being emitted toward your eyes, then by definition, something is arriving. Black occupies the opposite end of that particular relationship. It is associated with very little visible light reaching you from a region, which brings us back to the original question. Why is there no black light? Because black is not another wavelength waiting to be discovered somewhere beyond violet. It is a visual experience associated with the absence, or very low level, of visible light reaching the eye from part of the visual field. And once you understand that, something ordinary becomes surprisingly strange. The black shirt in your closet, the darkness between the stars, the shadow beneath your desk. They remind us that seeing a color does not necessarily mean there is a corresponding color of light physically sitting out there in the world. Physics provides the light. Your eyes detect it. Your nervous system processes it. And somewhere in that chain, the world you experience appears. So perhaps the strange thing was never that black light does not exist. The strange thing is that your mind can turn the absence of light into something you can see.